solve the equation, then check your solution. So to solve these equations, I need to isolate the variable, get the variable by itself using mathematical properties. Well, since I have two variables here, I would like to just get rid of one of them using addition or subtraction right away. So the best way to get rid of something is do the opposite thing to it. Here I have negative 11 n's. How would I make negative 11 n's become 0 n? I would just have to add 11 n's to it. And if I add something to one side of an equal sign, it's no longer equal unless I add the same amount to the other side of the equal sign. So I have 14 minus 10n, and just for the sake of clarity, let's go ahead and change this minus 10n to plus negative 10n. It means the same thing, but now it's a little more clear that I'm adding negative 10 with positive 11, and I'm going to end up with only one n. So I've got n, and I've got 14. 14 plus n, and over here negative 11n plus 11n is 0. I wanted 0 on purpose because now I don't have any n's on this side of the equation, and 0 plus 16 is going to be 16. Now I want to undo everything that's happening to the n so that the n stands alone or is isolated. So what's happening to n? Well, we're adding 14 to it. Well, how do you undo adding 14? We subtract 14. But if I take 14 away from this, it's not equal to the other side anymore unless I take the same amount off of the other side. So 14 minus 14 is 0, and 0 plus n is n, and 16 minus 14 is 2. So I've solved my equation, n equals 2. Notice the direction said, check your solution. So what I'm going to do now is I'm going to take this 2 and I'm going to plug it into everywhere there's an n in the original equation and just make sure that this side will equal this side when n equals 2. So 14 minus 10 times 2, what's 14 minus, 10 times 2 is 20. 14 minus 20 is going to be negative 6. Negative 11 times 2, well, that's negative 22, and then I'm going to add 16 to it. Negative 22 plus 16 is negative 6. It indeed does work. Negative 6 equals negative 6, therefore n is equal to 2 in this equation. All right, let's take a look at the next equation. We have fractions in this one, and many students really despise fractions or are very uncomfortable at the very least with fractions. So one way to get rid of fractions is multiply by the denominator of those fractions. If we take this equation, 4/5 b minus 4/5 equals negative 3/5 minus 1/2 b, and we multiply both sides of the equation by the denominator 5. Let's take a look at what happens. We have 5 times 4/5 b. Many of you like to do these problems in your calculator, but if you notice, 5 over 1, which is 5, times 4 over 5, 5 over 5 is 1. What you're left with is just the 4. So we could really just simplify this very quickly with the ones that have 5 as the denominator. 5 times 4/5 b, using the distributive property, 4b minus 5 times 4/5, 4, equals, and keep in mind we had to multiply by 5 on both sides, 5 times negative 3/5, negative 3, and this one is not quite as simple. 5 times 1/2 is 5 halves times b. So we got rid of the 5 fractions, but we didn't get rid of this last fraction here that was a 2. Well, we didn't multiply by the 2 fraction. We only multiplied by the 5. If we follow up and multiply everything by the other denominator, 2 times 4b, 8b. 2 times 4, 8. And on this side, since we multiplied one side by 2, we had to multiply the other side by 2. 2 times negative 3 is negative 6 minus, and 2 times 5 halves is 5 times b. Now we've simplified this and gotten rid of all of our fractions. Now we solve it the same way we had solved the previous problem. Now we could have solved the problem using fractions, but a lot of students just like to avoid fractions if they can, and this is a little trick that will help them at least avoid the fraction until they get to the solution section at the very least. So when we got two variables again, negative 5b or minus 5b and 8b, and we want to make one of these variables go away, I'm going to get rid of the minus 5. And how do you undo minus 5b? Well, you add 5b. And if you add 5b to one side of the equal sign, in order to keep everything equal, we've got to add 5b again. So 8b plus 5b would be 13b. Minus 8 equals, and minus 5b plus 5b would be 0. Negative 6 plus 0 is negative 6. So now we have 13b minus 8 equals negative 6. Undo everything happening to the variable. Well, the first thing happening in the order of operations here is we're multiplying by 13, and then we're subtracting 8. So we're going to undo all those things in reverse. The last thing we did was subtract 8, so we're going to undo that by adding 8. And if you add 8 to one side of the equal sign, you got to do the same thing to the other side of the equal sign, otherwise they're not equal anymore. We need to make sure they stay equal, so everything we do to one side, we do to the other side. 13b minus 8 plus 8, 13b plus 0 is still 13b, and negative 6 plus 8 is 2. How do we undo times 13? We divide by 13, and if we divide one side by 13, we divide the other by 13, and we find that b equals 2 13ths. Well, this one becomes a little more challenging to check your work. For most of my students, checking it on your calculator would probably be the most effective method here. So let's take a look at what we would need to, how we would type these fractions in our calculator. Because our graphing calculators don't have a fraction button to speak of, so we use the division button and we use parentheses to denote our fractions. So what we would put in our calculator would be 4 divided by 5 in parentheses, and 2 13ths, 2 divided by 13, so this would be 4 fifths times 2 13ths minus 4 divided by 5, and we would try to figure out what that equals, and I got a very long decimal, negative 0.67692307 and it looks like it's going to start repeating from the 7 here, 769230, 769230. Okay. In our graphing calculator using the TI-83, the way we would convert that to a fraction is to press the math button and select number 1 for fraction and press enter, and it gives us negative 44/65. But we really could have left it this way, because since we're just typing it in the calculator to check our answer, we should get the exact same number when we type the example in on this side of the equal sign. So now we're going to put in our calculator negative 3 divided by 5 minus 1 divided by 2 times 2 divided by 13. And I got the exact same long decimal. On the other side of the equation when I plugged in 2/13. Therefore, when I plugged in b equals 2/13, this side did indeed equal this side. Therefore, this had to be my correct answer. Looking at the next one, I'm going to go ahead and solve this one using the fraction rather than getting rid of the fraction, because some people find the extra steps of getting rid of a fraction more of a problem than actually working with the fraction. So let's take a look at doing this one with the fraction intact. 2 plus 2/5 times a plus 4 equals 4. And we're going to use the distributive property to simplify before we do anything else. We'll have 2 plus 2/5 a plus 2/5 times 4, which is 2 times 4, which is 8 over 5, 8/5 equals 4. Well, we have to combine like terms. We have 2 and we have 8/5. Many students like to convert 8/5 to its mixed number form, and 8/5 would be 1 and 3/5. So we have 2 plus 1, which is 3, and 3/5. So 2/5 times a plus 3 and 3/5 equals 4. Now we need to get a isolated on one side of the equation, solve for a. What's happening to a? Well, we're multiplying by 2/5, and then we're adding 3 and 3/5. So the last thing we were doing was adding 3 and 3/5. That's going to be the first thing we undo. So we're going to undo plus 3 and 3/5 by subtracting 3 and 3/5. So if we subtract 3 and 3/5 on one side of our equation, we've got to subtract 3 and 3/5 on the other side of the equation. And we have 2/5 a, and anything minus itself is 0, so 2/5 a plus 0, and 4 minus 3 and 3/5 is going to be 2/5. Well, this just became very easy, because the only number I can multiply with something and get the same number is the number 1. But to solve it out, just in the practice that everyone has seen before, we're going to divide both sides by 2/5, because that's the opposite of a times 2/5. And 2/5 divided by 2/5 is 1. 1 times a is a. And 2/5 divided by 2/5 is 1. So a equals 1. And when I plug in 1 for a, 2/5, actually now I can do 1 plus 4 is 5. 2/5 times 5 is 2, and 2 plus 2 equals 4, so that one checks out as well. So a equals 1 would have been my solution to the equation.